Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. An insurance company determines that n, the number of claims received in a week, is a random variable with probability that n is equal to 1 over 2 to the power n plus 1, where little n is greater than or equal to 0. The company also determines that the number of claims received in a given week is independent of the number of claims received in any other week. Determine the probability that exactly 7 claims will be received during a given 2-week period. Now, note that, of course, this number of claims in a given week, this is a discrete random variable because it can't be anything but a non-negative integer. The possible values are 0, 1, 2, and so on. The notation n greater than or equal to 0 doesn't clearly say that, but that's what's intended. N has to be an integer. So let's write n sub 1 and n sub 2 for the number of claims during weeks 1 and 2, respectively. Then the sum is equal to 7 when the numbers of the claims in the 2 weeks add up to 7, and that can only happen by adding 0 plus 7, 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, 6 plus 1, and 7 plus 0, which happens by taking the probability that n1 is equal to n times the probability that n2 is equal to 7 minus n, for n running from 0 to 7. And by the way, we can multiply these probabilities, even though we're talking about the probability of intersection of those two events, that n1 is equal to n, and at the same time n2 is equal to 7 minus n. The probability of that intersection of two events is the product of probabilities because these are independent events. So we're using the fact that n1 and n2 are independent. And then the first expression, probability that n1 is equal to 1 over 2 to the power n plus 1, and the second one is equal to 1 over 2 to the power 7 minus n plus 1, which is 8 minus n. So if we multiply it out, the n's cancel, and this is just the sum from n equal to 0 to 7 of 1 over 2 to the 9th. But the numbers 0 to 7, there's 8 of them, and we're adding up 8 identical quantities, so this is just 8 over 2 to the 9th, which is just 1 over 64, and that's answer D. Please remember, this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.